Hey guys, so let's discuss new round, which is round 7, and this is related to cloud and distributed systems. Okay, so again, let me explain that here we will be seeing answer for three roles like software engineer, senior software engineer, and architect. Okay, so this is the so we will discuss the one question. Okay, and then a few follow-up questions. So here we will be talking around 15 follow-up questions. So the question is. Okay, the question is that your e-commerce platform receives 10x traffic during a festive season. Okay, how would you prepare? So like generally how much request, whatever request you are getting, festive season you will be getting 10x request, right? Let's say because of the discount and everything, right? So how you will prepare for that, because you would be required a massive amount of servers and all, right? Means lots of servers. So see, this is the one of the most common Amazon SD, senior SD, principal architect interview question, because it tests your understanding of distributed system. Okay, first one. Second is your cloud architecture. Then after that, it's scalability, reliability, performance engineering. Okay, and cost optimization and operational excellence. Now, what is operational excellence here? So, operational excellence is the ability of an organization to consistently deliver high quality product or services efficiently. Okay, it's continuously deliver high quality product efficiently, reliably, cost effectively, while continuously improving its processes. Okay, so now it goes beyond simply reducing cost. It focuses on creating a culture where everyone works to improve performance, eliminate waste, and deliver greater value to the customers. Okay, so let's see the key principles of operational excellence includes. Okay, so what are the key principles of operational excellence? So here, customer focus, very first thing, right? Because you need to deliver continuously high quality product. So the first thing is customer focused. Okay, so like understanding and meeting customer need constantly. Then second is continuous improvement. Okay, so means regularly identifying opportunities to improve processes, product, and services, right? And then third one is process efficiency, so streaming workflows to eliminate waste, reduce delays, and improve productivity. Okay, now employee engagement. So empowering employees to solve problems, suggest improvement, and take ownership to their work. Then next is data-driven decision making, using performance metrics and analysis to identify issues and make informed decision. Okay, informed decision. Now standardization. So establish best practices so work is performed consistently across the organization. So these were the key principles. So you don't need to give this in detail. You should know that what is the operational excellence. Okay, and so now again, the expectation differs by level. Okay, so we were seeing the question, what was your e-commerce, let's say if your e-commerce platform receives 10x traffic, okay, during a festive sale, then how would you prepare that, right? So now see, software engineer is expected to answer uh, based on the building blocks. Okay, now, a senior software engineer should be answer related to design a production-ready, scalable system, and principal or architect would need to be answered like think globally, okay, prepare months in advance, optimize for reliability, cost, and business continuity. So now, what software engineer, 3 to 6 years of experience person will say for this? Okay, so what is the expected answer from him? Before the sale, I would identify the expected traffic increase, estimate system capacity, and remove obvious bottlenecks. Okay, so estimate system's capacity and then obvious bottleneck he will remove. I would ensure application can scale horizontally, reduce database load using caching, and move long run work to asynchronous processing. So here he is talking about caching and asynchronous processing. Okay, so like high level architecture is user request will go to load balancer, from there it will go to application 1, application 2, okay, horizontal scaling, and then from there it will go to Redis, okay, cache he is using here, and then database if it is not in Redis, okay, if it's a cache miss. After that it will go to Kafka, and then from there it will go to email or notification, okay, asynchronous processing. Now So what will be the preparation checklist for him? So it would be like increase application instances, okay, horizontal scaling, then enable caching, right? Then add read replicas. So you need to create replicas also, okay? And then replicas should be like read replica and write replica. So he's saying that add more read replicas, okay? And then queue background task, okay, for the asynchronous processing, and then perform load testing, monitor dashboards. So senior software engineer, 7 to 12 years of experience, what we are expecting him to answer. So expected answer would be preparation starts well before the sale, right? So I would estimate peak traffic, perform capacity planning. So he's also doing that, estimating the peak traffic, okay, what will be the highest traffic. He will be getting capacity planning on based on that, and then execute load testing and identify bottlenecks. The platform should scale horizontally, isolate critical services, okay, this is the different thing, isolate critical services, and use asynchronous processing wherever possible. So he's also saying the same thing almost, okay. So what will be the production architecture here? See, user request will go to global load balancer. From there, it will go to API gateway. Now, he was talking about isolate critical services, right? So here you can see that catalog service, cart service, payment service, inventory service, search service, different services. And then from there, it will go to Kafka. From there, it will go to this email service or analytics or order processing, okay, asynchronously, and then Redis cluster. And after that, it will go to database. And in database also, you have primary DB and read replicas, okay. So, yeah, that is how he will architect it like this, design it, something like this. Now, key improvement would be here, stateless application server, okay. We will see what is a stateless application server. And then second is horizontal auto scaling, Redis cluster, Kafka async workflow, and database read replicas, circuit breaker, rate limiting, and centralized monitoring, okay. These things are common for all the application. So stateless application server, what is that? So see, stateless application server is a server that does not store any client or user session data between request, okay. So no data sharing between request. First request is going, second request is going, no. One request will contain everything because we send the token, right? So that is how he will just came to know about the authentication part and all. Every request contain all the information needed to process it. Simple example. So suppose you are using e-commerce website, okay. So stateless, if you have a stateful server, then what will happen in that case? First login request will go, okay. So server store your session in its memory. Then after that, add to cart. When user click add to cart, so that time server looks up for session in memory. Then third one is checkout. So same server must handle your request because it has your session, okay. So stateless server, if we talk about, so currently we have seen a stateful server, okay. So there he's storing many places, like for example, first in memory, second the session information in memory, then third one is again same server must handle the request because you have stored that session in one particular server, right? So second time when the request is coming, it should go to the same server, right? Then only he will find the session, otherwise how he will find it? So stateless server, now here the stateless server things comes, okay. So like for example, if user has login, so server return JWT token. Now when user click on add to cart, so client send the token with the request, okay. He got the request, he got the token, and then from every request he will send this token. Now at the time of checkout, client again send the token, okay. So we don't need to store any information on the server. First time we have given him a token, and from next time onward, client will send that token with every request, right? So any application server can handle request because no server is storing your session. So now here request can go to any server, okay. Here you can use the concept of scalability, auto scaling and all, right? So why use stateless servers? Easy to scale, right? Simply add more server behind a load balancer. Initially, what was the problem? You were storing session in a server, so next time when request comes, it should go to that server only. So there is no point if you have added multiple servers or not, okay. Every time you're using the same one. So that's why. Now second is high availability. So if one server crashes, another can immediately handle the request. Okay, and then simpler deployment, servers can be restarted or replaced without affecting users. And then better load balancing, so request can go to any server. Okay, now principal engineer or architect, what he is expected to answer for this is see, festival traffic is a business critical event, right? Because their business generate lots of profit. So preparation begins months in advance. I would define capacity target. Okay, again he's talking about capacity target. Then perform game days. Okay, what is game days? We will see. So here we will see, and then validate disaster recovery, and if anything happens, then how you will handle that. Okay, disaster recovery, and ensure every layer of the platform can scale independently. The goal is not just handle 10x traffic, but maintaining customer experience under extreme load. Okay, so now what is game days? So game days are planned exercises where team intentionally simulate failure or incident to test whether the system monitoring or people can handle them effectively. Okay, so now let's see the architecture from principal software engineer side, right? So see, route 53, okay, will send the request to your global traffic manager. Here he will talk about the wider level. Okay, here he will talk about the region based deployment or multi-region deployment, you can say. So that's why route 53 will send the request to global traffic manager. Okay, and then from there it will go to multi-region load balancer, not simple load balancer but multi-region load balancer, which will route your request to multiple regions. Now here you will have a region A, region B, okay, replicas of the region, where you will have the API gateway, okay, then catalog service, let's say cart service, inventory, payment, recommendation services, all these things. And now Redis cluster, okay, not single Redis server, but the Redis cluster, and then database replications, and then global CDN, right? So now design principles, if you talk about here, so he will be using active region. Okay, you have active region and active passive region. So active region means in both the region you will deploy, and both the region are functional. Okay, so you are sending request to any of the region, and it will cater the request. Active passive is only one region is working. If it will goes down, then only we will use the another one. Okay, now sale based architecture, because your application is using by entire using means getting used by globally, right? So we have divided the globe in the region wise, sale wise. Okay, so that's why sale based architecture. Then zero single point of failure, progressive traffic rollout. Okay, first we will roll out traffic to 5% and then 10%, and then we will increase it. Okay, it depends on your deployment strategy, which deployment strategy you're using. And then auto scaling at every tier. Okay, and then continuous observability, cost aware resource planning, right? Now let's talk about some follow-up questions. So we will be seeing here 15 follow-up questions. So the first one is they will talk about auto scaling. Okay, so how you will manage auto scaling here. So all three roles will give their answer. So let's see what software engineer will say about auto scaling. He will say configure auto scaling based on CPU utilization or request count. So new application instances are added automatically during traffic spikes. Okay, so how he is calculating it using the CPU utilization and request count. He will monitor that, and if it cross particular threshold, then he will include the more servers. Okay, senior software engineer will say that scale multiple metrics such as CPU, memory, request rate, queue depth. Okay, keep the baseline capacity to avoid cold start. So here he has added more metrics. Okay, more metrics like CPU and memory already we were using. Now he's seeing here checking a request rate and then queue depth. So you are using queue there. Okay, and queue will have some capacity, right? So it will check the queue. Okay, when that queue is full, okay, or it will reach to particular threshold, then only you add the auto scaling servers. And he is talking here about cold start also. Okay, so keep a baseline capacity to avoid cold start. Cold start means it will take some time, right? If you are adding new server, so there would be some processes will happen on that server, right? It will take some time, so that should not happen. So that's why you have to keep the baseline capacity. Okay, to avoid this cold start problem. So keep a baseline capacity to avoid cold start means always keep a minimum number of server or instances running even when traffic is low, so the application can respond immediately new request. Okay, and meanwhile he will create the another servers. Okay, so now architect will answer for this is use predictive autoscaling based on the historical sale pattern, pre-warm capacity based on the events, and validate scaling behavior through load test. Okay, so he is talking here about predictive autoscaling on what basis? Historical data. Okay, historical sale pattern. And then he is talking here about pre-warm capacity. Pre-warm capacity means he will already ready few servers. Okay, so before the event, like this is to avoid the cold start problem we saw. And then validate scaling behavior through the load testing. Now follow-up 2 question is related to load balancer. Okay, so software engineer will say about load balancer, distribute incoming request across multiple application instances, right? This is the normal straightforward definition of the load balancing. Now senior software engineer will say use health check and then session independent services and weighted routing to improve reliability. So here in load balancer he has added health check. Okay, for the each server. So load balancer will send requests to different servers, right? So he will check the health of the server also. Okay, if it is ready, if it is good, then only he will route the request there, otherwise he will route request to somewhere else. So session independent services. Okay, so it means that one particular server is not storing the session value. It's a session independent services. You can send to any server and that server will cater the request. And then weighted routing to improve reliability. Weighted routing we have seen in load balancer, right? Round robin. So we will assign some weight to the server, and then whoever have the more weight, more request will go to that server. Now weighted routing means sending different percentage of traffic to different servers, region, application version based on the assigned weights, right? Because you will not always have the identical servers. Okay, some will have the more resources, some will have the less resources. Okay, so it means that some server can get a more request, right? So that's why. Now or if any server goes down, you just reduce its weight. Okay, and then just increase the weight for the other server, so request will go there. Now it's common to use high availability, gradual deployment, and improving reliability. Okay, this weighted routing we were talking about. Now example 1 is multiple region. Okay, let's say you have multiple regions. So suppose your application runs on 2 regions, so region 1 and region 2, region A and region B. So your traffic, like 80% traffic is going to region A, 20% traffic is going to region B. Okay, so now if region A starts having issue, you can quickly change the weight. Okay, so region A will become 20% and region B will become 80%. So this reduces the impact of failing region without a complete outage. Now example 2 is canary deployment. So now what is canary deployment? You are deploying a new version of your shopping cart service, let's say. So initially version A is stable, which is already stable. So you will send 95% traffic to that version, and version B is the new version. So there you will see you will send 5% traffic. Okay, so if version 2 performs well, then you just change the traffic, right? 50% and then 100% and 0%. Okay, now if any error occurs, then in that case change the weight back to 100% for version 1. User are protected while you are investigating the issue. So why does it improves the reliability? So instead of sending all traffic to one server or one new deployment, you spread traffic across healthy instances, reduce the impact of failure. Okay, then detect issues early with a small percentage of user and shift traffic away from unhealthy regions or version without downtime. Okay, now what architect will say for this? Use global traffic management with regional load balancer, health-based routing, and then automatic failover. So here he is talking about global traffic management. Okay, with regional load balancer. So like load balancer is based on the region. Okay, regional load balancer. Okay, so now and then automatic failover also he is talking here. Okay, anything failed, so the request should go to another one. Now follow-up question 3 is related to cache strategy. Okay, so software engineer will say he will cache the product catalog detail, okay, and then product images, and then search results. All these things he will store in a cache. Senior software engineer will say that he will use Redis for application caching and CDN for static content. Define proper cache invalidation and TTL policies. Four things he's talking here. Okay, first one is Redis, okay, for the application cache for storing all these things. CDN for static content, okay, and then of course you are using cache, so you have to give cache invalidation policies also, and TTL, right? So now what architect will say, implement multi-region, multi-level caching. Okay, so like CDN, then edge cache, Redis, and application cache. So continuously monitor cache hit ratios and optimize invalidation strategies, right? So he's talking here about optimizing the strategies, invalidation strategies. Follow-up 4 is related to database read replicas. Okay, so software engineer will say that send read request to replicas while write continue to the primary databases. I told you that you will have a one primary database, okay, where you will perform your write operations, and you will have a multiple read replicas. So for the read request, you will send traffic there. Okay, so senior software engineer will say separate read and write workloads and monitor replication lag during peak traffic. Okay, replication lag during peak traffic. So this is one he's talking about. Now what architect will say, combine read replicas, partitioning, and caching. Okay, so he's talking about high level. So instead of read replicas, he has added partitioning also and caching also. Okay, so he will combine all three things, and then ensure application tolerates eventual consistency where appropriate. Eventual consistency. Okay, now follow question 5th is queuing. So software engineer will say move long running tasks such as email or notification to a message queue, right? We will introduce this now. What senior software engineer will say, use Kafka to decouple producers and consumers so traffic spikes don't overload downstream services, right? So so all the extra requests will wait in a queue, and then one by one you will the downstream services will use it, will work on that. So now architect will say treat queue as a buffer during peak events, okay, and monitor consumer lag and prioritize critical workflows. Okay, follow-up question 6 is related to async processing. Okay, so async processing means software engineer will say like this kind of task, right? Email, SMS, invoice generation, all these things will be done using async processing, okay, which you can do later. It's not a critical that you have to do right now. So for that, you just run that in async pipeline, right? Now senior software engineer, what he will say, publish events after order creation. So downstream services processes them independently. Okay, now here he is talking about publish event, and now architect will say build an event driven platform where analytics, recommendation, notification, and reporting consumes events asynchronously. So again he's talking here about event, but he is talking here about event driven platform instead of event publishing, right? So he's talking here about platform. Okay, follow-up question 7 is related to inventory synchronization. Okay, so now what is inventory synchronization? Software engineer will say update inventory immediately after a successful purchase, right? So you have an inventory in a warehouse, okay, a customer has purchased anything, so you just immediately just update that. Senior software engineer will say that reserve inventory during checkout and confirm the reservation only after successful payment. Okay, just have some log, and after some time if the payment failed or not happening, so release that log. Okay, so just reserve inventory during checkout time. Now what architect will say, inventory should managed by the dedicated inventory service using reservations, event driven updates, and saga based compensation to prevent overselling, right? Here he is talking about the architect level. So talking about that inventory should be managed by dedicated inventory service, okay, and using reservations, so you can reserve the inventories, and then event driven updates and saga based compensation to prevent overselling. Okay, so saga based compensation means if anything fails, any transaction fails, so he will compensate the event, he will refund the money, right? So now follow-up 8 is related to flash sale handling. So flash sale handling means Software engineer will say that limit the number of requests entering the checkout flow to prevent system overload. Okay, so limit the number of requests, he's saying. Senior software engineer will say use virtual waiting room, queue, inventory reservation, and rate limiting to smooth sudden traffic spikes. Okay, he's talking here about multiple things like virtual waiting room you use, or you use the queue. Okay, if any suddenly the request came, right, spikes in the request, so virtual waiting room you can use, so request will wait there. And then queue you can implement. After that, inventory reservation, rate limiting also you can use, right? Architect will say implement admission control, admission of a request. Okay, now distributed queue, inventory tokens, and fair scheduling so customers experience predictable behavior under extreme demands. Okay, now follow-up question 9 is related to hot partitioning. So now what is hot partitioning? Software engineer will say that a very popular product can overload a single database partition. Okay, one product, Apple iPhone, okay, let's say everybody wants to buy that. Okay, so it's a database. So it will overload all the requests to database, right? So you just have the database partitioning, and then the request will go to each partitions, so it will distribute the load, right? Then senior software engineer will say use better partitioning key, okay, on which basis you are partitioning the data. Then caching and request distribution to reduce hotspot formation. Okay, now architect will say that design partitioning strategy. Okay, now here he is talking about a strategy, partitioning strategy that avoid skew. Skew means all one, like a skew tree, you know, right? Like which have only the left nodes, so that is the left skew tree. Which has only the right node, that is the right skew tree. So okay, what was the problem there in the left skew tree and right skew tree? Let's say you have to search one element. Okay, so in general, if it is a binary tree, so binary search tree, so the complexity would be order log n. Okay, because either you will search that element in a left subtree or in a right subtree or the root, right? So every time it will exponentially decrease the things. But here in skew binary tree, you have to traverse each node, right, until you don't find the element. So here the complexity will always be order n. So that was the problem in skew binary tree, right? So here also design partitioning strategies that avoid skew, use consistent hashing where applicable, and isolate hot products with dedicated cache capacity. Now follow-up question 10 is related to throttling. So throttling, software engineer will say reject requests that exist predefined limit. Okay, I've already predefined some limits. So if the request is um, means exceeding that limit, so we will just reject it. Like in 1 minute I will get a 1000 request, and more than that I will just reject it. Okay, so my system will not go down. And senior software engineer will say apply rate limiting at the API gateway level using token bucket or leaky bucket algorithm. Okay, now here he's talking about API gateway. Now architect will say that use adaptive throttling. What is adaptive throttling here? Based on service health, so critical APIs remains available even during overload. Okay, based on the service health. Follow-up question 11 is related to circuit breaker. If any service is failing, then it will just break the circuit there, so that it will not fail the cascading, it will avoid the cascading failure. Okay, so software engineer will say that stop repeatedly calling a falling service to prevent cascading failure. Okay, now software engineer will say senior software engineer will say configure timeouts. Okay, retries with exponential backoff, and circuit breakers for all downstream dependencies. Okay, so circuit breaker, exponential break off, retries with exponential back off. Exponential back off means add some time. So you earlier you were retrying it in every 1 second. Now retry it in 1 second, then 1 second, 1.2 second, then 1.4 second, 1.6 second. So just add some exponential delay there. What architect will say about circuit breaker is that circuit breaker should be integrated with service health, fallback mechanism, and automated recovery policies. Okay, okay, now see here he is talking about circuit breaker should integrate with service health. Okay, so service health and then fallback mechanism also. Okay, what if it is not working, that service is not working, then what should return? Okay, so fallback mechanism should also be there. And automate recovery policies, how you will recover that service. Okay, follow-up question 12 is related to graceful degradation. What is graceful degradation? So software engineer will say if recommendation fails, so continue allowing user to browse and purchase product. Okay, so if recommendation service is failing, at least just have the critical business things continuously going on, right? Like browsing the product, purchasing the product. So senior software engineer will say that disable non-essential features such as recommendation or recently viewed product while keeping checkout operational. Okay, so just disable non-essential services like checkout or sorry, not checkout, recently view or recommendation, this kind of services, but checkout is important here, so keep that. So that is how you will do this one, graceful degradation. Now soft architect will say that prioritize business critical workflows. So what is the business critical workflow? See, first user should be able to browse the product, then he should able to cart add into the cart, okay, then checkout, and then payment. So these four things are very important. Apart from this, recommendation service, recently viewed, history, and all those things will come later. So non-critical feature can be temporarily reduced or disabled during overload. Okay, if lots of request is coming, so just disable those things and just have the prioritize business critical workflows in that condition. Now follow-up question 13 is related to cost optimization. Okay, so cost optimization, software engineer will say that is scale down unused resources after the sale, right? Earlier you were using 10 servers, and now after sale just reduce it to 2. Senior software engineer will say that use auto-scaling, reserved capacity for predictable workloads, lifecycle policies, and optimize cache utilization. Architect will say balance performance and cost through predictive scaling. Okay, spot capacity for non-critical workloads. Okay, we will see what is the spot capacity, storage tiering, right sizing, and continuous cost monitoring. Now here are simple explanation of each part. So here we talk about lots of things, right? Predictive scaling, then spot capacity, then non-critical workloads, storage tiering, right sizing, continuous cost. So see, first is predictive scaling. What is predictive scaling? Meaning that scale server before traffic increases by using historical traffic pattern. So example, an e-commerce website knows traffic spikes every day at 8 a.m., 8 p.m. Okay, so instead of waiting for the CPU usage to rise, it automatically start more server at 7:50 p.m. only 10 minutes earlier, right? Ensuring users don't experience slowdown. Now, spot capacity for non-critical workloads. Okay, so what is the spot capacity? Use low-cost spot instances for workloads that can tolerate interruptions. Okay, interruptions means those were the free servers. Okay, you will use that, so it would be a cheaper. Why cheaper? Because your server provider can take back that server again. Okay, if anything important happens, someone wants that server, so it will take that. So just assign some workloads which can handle the interruptions. Okay, it's okay if means again when the new server will be assigned to you, your process will start from the point where you have left. Okay, so for example, generating product recommendation overnight. Processing analytics can run on spot instances. If the cloud provider reclaims that, the job can simply restart later. Now storage tiering. So tiering, so meaning store data in different storage classes based on the how often it is accessed. For example, hot storage means active shopping carts or recent orders you can store there. Then warm storage, so order from the last 6 months you can store there because we don't use that much, right? Cold storage, order older than 2 years for compliance you're storing there. Okay, so hot storage, warm and cold, the prices are different, that's why. So this reduces storage cost while keeping frequently accessed data fast. Right sizing means choose the appropriate server size, not too big, not too small. If the application uses only 20% CPU on a large virtual, let's say large VM, so move it to smaller, cheaper VM, right? If it consists constantly 95% CPU, upgrade to a larger instance. So continuous cost monitoring. What is continuous cost monitoring? Continuously track cloud spending and detect unnecessary cost. So for example, a dashboard or alert notify the team if an idle database is still running, and then storage cost suddenly increases and a new deployment doubles cloud expenses. So it will just alert the system. This helps teams fix cost issue before they become expensive, right? Now, follow-up question 14 is related to multi-region failure. Software engineer will say that deploy the application in multiple regions so traffic can be redirected if one region becomes unavailable. Senior software engineer would say that replicate critical data or perform health check and automatically reroute traffic to healthy region. Okay, if anything, multi-region failure, any region failed in that case. Architect will say adopt active region deployment, regional isolation, automated failover, and regular disaster recovery exercises to ensure resilience. Okay, so disaster recovery exercise he's talking about, automated failure he is talking about, and then regional isolation and active regional deployment. Now, follow-up question 15 is related to capacity planning. Okay, so how you will do your capacity planning. So software engineer will say that estimate expected request, database load, storage, and network bandwidth before the sale. Senior software engineer will say use historical traffic growth forecast or load testing results to determine required capacity with an additional safety margin. And principal software engineer will say that capacity planning is an ongoing process. Okay, I would analyze previous sale event and growth trends, then define expected peak RPS, concurrent users, storage, and bandwidth. Okay, then RPS means request per second. So, and then load test beyond the expected peak. Okay, like for example 15x instead of 10x. We are talking about 10x load, right? But he will do load testing on 15x. Now, verify auto scaling behavior and database limit. Identify single point of failure. Conduct game days and kiosk testing. Okay, game days we have seen that. And establish SLO, RTO, and RPO. That we will see here. What is that? Then continuously monitor capacity during the event and adjust proactively. Okay, so now SLO is service layer objective. Okay, so meaning the target level of service you aim to achieve. RTO is recovery time objective, so meaning the maximum acceptable time to restore a service after an outage. And RPO means recovery point objective, meaning the maximum amount of data you are willing to lose after a failure. So that was the round 7. So thank you.